Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Social Sciences, SOSS. Postgraduate Diploma in Disaster Risk Reduction and Management, PGDDRRM. MPA031 Physical Geography. Block-1 Geomorphic Processes. Unit-5 Fluvial Karst and Glacial Landscapes. 5.0 Objectives. After studying this unit, you should be able to discuss the meaning and concept of fluvial, karst and glacial landscapes. Explain the formation of different landforms produced by fluvial, karst, and glacial actions. Discuss and differentiate between erosional and depositional landforms. 5.1 Introduction. In Unit 4, you have studied about exogenic processes continuously active on the surface of the Earth. You must have observed that water flows from higher altitude to lower along the slope. The areas where chemically reactive rocks are found, rocks are weathered and eroded easily by chemical action. In the areas where temperature is less than 00 Celsius, ice is found particularly on higher altitude and polar region. They are said to be fluvial, karst and glacial dominated regions, respectively. They are fluvial, karst and glacial agents of landscapes development. It is worth mentioning here that running water or river is active in humid regions. Underground water is active in the regions where limestone chalk, gypsum and dolomite-like soluble rocks are found, and glaciers are active in high altitudes and high latitudes regions of the world. The area dominated by running water is known as fluvial landscapes. Area rich in limestone, dolomite, gypsum or chalk with water availability is known as karst landscapes. Glacial landscapes are found in high altitude and high latitude regions of the world. In this unit, we will learn about the formation of landforms developed by these three agents of erosion. 5.2 Fluvial landscapes. Fluvial landscapes are those which are generated by running water or mainly rivers. The term fluvial derives from the Latin word fluvius, that means river. Fluvial landscapes are observed from the source of the river to its mouth. River or running water is a normal agent of erosion in humid regions. According to normal cycle of erosion, learnt in Unit 4, the fluvial landscape can be compared with three stages of human life. A human being completes its life through three stages: youth, maturity and old. In the same way, the cycle of erosion is supposed to be completed through three: youthful, mature, and old stage. Since the characteristics of all the stages are different in terms of altitude, slope, erosive power and carrying capacity of the river, the landforms produced are also accordingly different. The landscape of any area is the function of weathering, erosion, transportation and deposition by different agents of denudation. Let us discuss them in brief. The details of weathering are discussed in Unit 4. Erosion is detachment and lifting of rock particles. Detached and lifted particles are moved forward according the transporting ability of the agent. Once the ability to transport is reduced, carried particles are deposited. Transportation connects both erosion and deposition and helps in forming different kinds of land features. These landforms are of two kinds: erosional and depositional. Erosion is performed in four ways: I. Abrasion, corrosion; E. Attrition; E. Hydraulic action; and IV. Solution, corrosion. The loads carried by running water grind the flow path, river bed and its side. Hence, erosion of bed and side of river is termed as abrasion or corrosion. The reduction of the load by striking the bed and side as well as hitting the loads among themselves is known as attrition. The friction caused by the flow of running water causes the rock to reduce. It is termed as erosion due to hydraulic action. When soluble minerals of the rock are dissolved in water, it is called erosion by solution or corrosion. Transportation occurs in four ways: I. Traction; E. Saltation; E. Suspension; and IV. Solution. Larger and heavier gravels lying on steep slope are rolled along the river bed. Hence, erosion of bed of river is called traction. When medium and smaller sized boulders, rock fragments are moved forwarded by leaps and jumps, like frogs leaping, jumping, it is called saltation. When very small and tiny rock particles are carried through the flowing water body without putting back at the surface is termed as suspension. Solution is the name given when the soluble substances, minerals of rock are removed by dissolving them. Deposition by running water is caused by I. Slope decrease, E. Reduction on water volume, E. Load increase, and IV. Lowering of water velocity or decrease in water depth. Now, let us discuss the land features in a sequential of their development. 5.2.1 Youthful stage. River originates from higher altitude and drains downstream along the general slope. The first flow of water is in the form of small rills and gullies. Initially, slope is very steep. First stage of river cycle is characterized by the formation of some distinct landscapes. According to Davis, river remains in the first stage in mountainous region. In this stage, erosional work is significantly very high and erosional features are developed by the river. This stage is also known as upper course of river. After development of small rills and gullies, I-shaped valley is formed due to rapid valley bottom erosion, downcutting and very slow rate of lateral erosion. Therefore, the deep and narrow valleys are developed due to downcutting, popularly known as gorge. Due to slow rate of lateral erosion, water divide remains wider in young stage. Actually, water divide divides the area drained by two rivers in two different directions. River capturing is an important feature of young stage. Due to headward erosion, when a river erodes towards its source, it captures the water of another river. The point where a river captures another river, it is called elbow of capture. After some time, the bed of river with steeper slope and deeper valley drains almost entire water. Hence, the downstream valley of captured river is devoid of water. Fig 5.2. Since captured river has more water, its bed is deeper, its downstream continuation has higher bed, and hence, it is called misfit river. Look at the screen. Figure 5.2, river capping. In mountainous region, rapids, cascades, springs and waterfalls are formed due to different arrangement of hand and soft rocks. Rapids are areas of fast-flowing water with shallow depth in the Fig. 5.3, Rapids and Cascades source, author. River flows through narrow and deep valleys during first stage or young stage. When there is an abrupt break in slope along a river path, especially at the foothill, alluvial cone or alluvial fan, Fig. 5.4, is formed. It happens due to more and more deposition of sediments caused by lowered ability to transport by the river. When the slope of deposited sediment is steep, it is called alluvial cone. When the slope of the same is relatively gentle, it is termed alluvial fan. Mountains, higher slope. As the name is self-explanatory, waterfall is fall of water vertically from a resistance rock in its path. Where water falls, a plunge pool is created due higher erosion of falling water. When a series of small waterfalls are found, it is known as cascades. Fig. 5.3. When seeped water into rocks reappears slowly on the slope is called spring. 5.2.2 Mature stage. When river leaves mountainous region, it enters into plain. It is generally termed as mature stage. This stage is characterized by lateral erosion as slope is lowered in comparison to the upper course. Hence, prominently vertical erosion in upper is replaced by lateral erosion. Therefore, narrow and deep valley is converted into wide and open valley. Relief and slope become lower due to negligible vertical erosion in the plain. During mature stage, river flows in along a curved path and creates some typical landscapes. Among them, natural levees, oxbow lakes, floodplains are some important landforms. The velocity of the running water in plain area is slower as the slope is lesser. It also carries huge amount of smaller sized debris. Under appropriate conditions, river deposits its debris even in its path. Depositions of sediments in its bed lead to meandering. Meander, Fig. 5.5, is erosional cum. Depositional landscape. Erosion at one bank is associated with deposition on the other. At erosional bank, river water depth is more and cliff-like feature is created. At this place, the slope is concave. It is also termed as cut bank. On the other bank, deposition is prominently observed. Water depth is low and it is called point bar. At this place, the slope is convex. Look at the screen. Fig. 5.5. Meandering of Gomti River before its confluence with Ganges. Due to higher erosion, the outer curve of meander gets closer. The inner curve of loop gets disconnected from the channel. When the loop of meander is separated by erosion of the meander neck from the flowing water, Oxbow Lake, Fig. 5.6, is formed. It is separated as independent still water body. Fig. 5.6, Meander and Oxbow Lake. Flooding is a natural process in the plain. When the amount of water is excess, it overtops the banks of river. At the bank, outside the channel, the flood water velocity is slower. Since the lesser depth of water and more friction cause deposition of sediment along the river bank. In due course of time, river banks become higher than the surrounding outside the area. This higher linear bank of the river is known as natural levees. After overtopping the bank, natural levees, flood water spreads over a large area. Whatever the sediment is carried by flood water, it is deposited over the entire area up to which the floodwater reaches. Therefore, whole of the area covering floodwater is known as flood plain. Currently up to which flood water reaches is also termed as cotter. The area of flood plain up to which the floodwater is not reaching currently is termed as banger. In a well-developed plain of a large river, some of its tributaries are running parallel to the main river. After running for a considerable distance, it joins the main river. Such tributaries are called Yazoo rivers. 5.2.3 Old stage. The lower course of the river is considered as the old stage of the river, since the slope is very negligible. In this stage, the youthful energy of the river is completely missing. It flows very slowly and calmly. It all happens due to negligible slope. Hence, the sediment brought from the upper or middle course is deposited. The river reaches to a level where even tiny-sized sediments are completely deposited before it empties its water into the ocean or sea. Due to very low slope, sediments are deposited into its bed. Water is forced to get divided into several channels. Those several channels are known as distributaries. These distributaries distribute the river water into oceans, and hence, they are called so. Deposition of sediments by distributary system of river forms delta at the mouth of a river. Fig. 5.7. Delta is, generally, a triangular-shaped depositional topography formed at the mouth of the river. It is also known as arcuate or fan-shaped delta. Their classical example is Ganges delta. Depending upon the local situation, the shape of the delta may be of different kinds as well. Bird's foot delta is termed when the shape resembles like bird foot's claw. Its example is delta of Mississippi of the USA. Estuarine delta is formed where ocean wave is strong and deposited sediment is carried away into the ocean. Hence, the mouth of the river remains open and empties into ocean. Its very good example is delta of Narmada River. Fig. 5.7. Types of deltas. Look at the screen. 5.3 Karst landscapes. Karst landscapes are well developed in the areas of chemically reactive rocks. Rocks like limestone, dolomite, chalk or gypsum are chemically reactive or they get dissolved when comes in contact with them. You have already studied about the chemical weathering in Unit 4 of this block. One of the best developed such landscape is in Karst area of Adriatic coast of Yugoslavia. Hence, the termed Karst landscape is given to such resembling areas. Ideal conditions. Topography made by groundwater or karst topography is well developed in the areas where large deposits of limestone or dolomite or such type of rocks are found. They are thickly bedded, fractured and well jointed. They are exposed to air and water. They lay in warm and humid areas. They are above the groundwater table, and there is good drainage system to removal of water. On the basis of location and formation of the features, the karst topography is grouped into two categories. I. Topographical features formed on the surface such as lapis, sinkholes, swallowholes, doline, uvala, polge etc. E. cave and related landscapes. 5.3.1 Surface karst landforms. Lapis is a rugged topography developed in limestone surface region due to dissolving of calcium content in the rocks. It is characterized by a series of interconnected tiny ridges and shallow channels created by chemical weathering process and dissolution of rocks. It is such a rugged topography, over which it is difficult to walk in such areas. Sinkhole. Sinkholes are found on the surface of limestone or dolomite regions. When water enters in the interior through joints of limestone or dolomite, funnel-shaped topography is developed at the head of the joints. That funnel-shaped topography is known as sinkhole. Its depth varies from 3 to 10 meters. Fig. 5.9. Sinkholes. Look at the screen. Swallow holes. In karst region, several sinkholes are formed. Due to gradual and continuous enlargement of sinkholes, several adjacent merged together. Their size becomes enlarged. Through the internal joints, rocks are dissolved and a passage of water is created through which smaller rivers may even disappear. This large depression on the surface and its connection with internal drainage is termed as swallow hole. Doline. When nearby swallow holes are further enlarged by continuous solution and are merged together, they are known as dolines. Uvala. Coalescence of several dolines forms the larger-sized depression on the surface is termed as uvala. The stagnation of water in uvala forms a permanent lake in limestone regions. Polge. Polge is the larger size of uvala. It is characterized by vertical sidewalls and flat alluvium deposited floor with large depression. Stagnation of water in the polge creates a lake. Fig. 5.10. Karst landscape. Look at the screen. Blind valley. Blind valley is that type of valley in which there is no outlet of flowing water on the surface. It is formed when a smaller river flowing through karst region disappears and water becomes underground through dolines. The valley through which water becomes invisible automatically, through dolines, is known as blind valley. 5.3.2 Cave and related landscapes. Under the surface of the earth, a hollow space is created by dissolution of rocks by chemical cation on such reactive rocks. It is formed in the region where thick deposit of limestone is found. Its size varies from very small to very large depending upon the deposits of limestone and chemical actions. This hollow is termed as karst cave. In karst region, chemically dissolved rocks are drained out through underground stream channels. Water seeps through the roof of the cave from several joints. In this process, a huge hollow underground cave is created. The water dripping from the joints and holes into the cave. Fig. 5.12. Cave, stalactite and stalagmite. The dripping water from the roof dilutes the lime content. The drip is slow and, in this process, some part of the lime is solidified by evaporation of water from the dripping surface. With the passage of time, it keeps on enlarging in its width and length. Enlargement in width makes it thicker and downward growth increases its length. This feature hanging from the roof is termed as stalactite. Below the stalactite, dripping drop of lime dissolved water falls on the surface of the cave. Since it is rich in lime, some part of it is solidified and there and rest is drained out. Hence, a rising structure at the falling point of sipped water is seen. It also keeps on growing in width and length. Increase in length vertically is observed. It known as stalagmite. When the growth of both stalactite and stalagmite leads to getting both joined together, it is popularly known as cave pillar. Landscape is the characteristics of high latitude and high altitude regions of the world. Glacial landscape develops are found above the snowline. There are 3 types of glaciers. They are alpine continental and Piedmont glaciers. Alpine glaciers are the features of high altitudes, continental glaciers are the features of high latitudes, and Piedmont Glacier is the feature of foothills where the temperature is below freezing point. Several distinct features are developed by glaciers. They can be classified under 2 broad categories: I. Erosional features and E. Depositional features. 5.4.1 Erosional features. All the erosional features are the creation of erosion. They are mostly developed in alpine glacier regions or in mountains. There are several landforms created by erosional action by the glaciers. They are: U-shaped valley. Glacier is a solid body of ice which moves down slope very slowly. Since it is solid, it exerts huge pressure on the surface. In this process, it tries to make a U-shaped valley. When a glacier occupies a pre-developed V-shaped valley by river, it creates U-shaped valley. Hence, river valley of V-shaped is transferred into U-shaped valley by glaciers. Fig. 5.13, U-shaped valley, hanging valley. Look at the screen. The erosive power of the glaciers is determined by the slope of the surface and the amount of accumulated ice. When the slope as well as amount of ice is more, it erodes more. Therefore, greater erosion is observed. Valley becomes deeper. It is quite obvious that there is smaller quantity of ice is there in the tributary glaciers. Hence smaller amount of ice erodes lesser in comparison to the main, primary, glacier. Therefore, the difference in the thickness of the glacier is responsible for the formation of hanging valley. Fig. 5.13. Just like main river, the main glacier has more thickness of ice in comparison to the tributary. It results into the differences in bed level. When the tributary glacier meets the main glacier, it is seen hanging over the main glacier. When the ice is melted, or glacial age is over, they are visible. Several examples of hanging valleys are observed in the Himalayan region. Look at the screen. Fig. 5.13, Glaciated landscape. Source: Wikipedia, United States National Park Service. Public domain. Cirque is like an armchair in shape found in the upper part of glacier. When a glacier starts from a peak of a mountain system, it has a very steep wall-like structure. At the bottom, it is a basin-like depression. To the front, it is like a threshold with a little higher blocking of the depressed basin. Its slope is concave. The height of the frontal part of a cirque is high due to deposition of debris. Once the glacier is melted, water get accumulated in the cirque. This accumulated water is termed as cirque lake or tarn. Fig. 5.13. Arête. When cirques are developed on both sides of a ridge, arête is formed. The boundary between two adjacent cirques gets narrower and sharper due to erosion. A sharp edge is created called arête. Tracking, climbing is dome along the arête because it has lesser slope in comparison to the climbing through the cirque. When three or more glaciers developed along a peak from different direction, the peak becomes sharper and narrower. Fig. 5.13. This peak is known as horn. Fig. 5.13. Roche mutiny. The effect of glacial erosion is also seen on the floor, surface. Such type of effect can be seen in both continental and mountain glaciers. Continental glaciers are wider. Hence, there is a possibility of rocky hills, or rocky mounds come in their path. In such a situation, the slope in front of glacier, SOSS side, of that rocky mound becomes softer and smoother due to abrasion and the leeward side slope becomes rugged, rough due to glacier, snow pressure. Such developed landscape is termed as Roche mutiny. Fjord. When a glacier reaches at the sea, oceanic coast, it performs erosional work. At the coast, huge iceberg reaches to the coast. That iceberg also carries load, erosive tools of the glacier at the bottom. Since huge iceberg exerts high pressure on the ocean bottom, erosion is performed below the sea level. Hence, greater erosion creates fjord, which is an extension of the ocean. Inside the land, the western coast of Norway is famous for such type of coast. These types of coasts are suitable for natural ports fish industry. 5.4.2 Depositional features. Deposition occurs when the carrying capacity is reduced. Different sizes of loads are carried by glaciers. When they are getting deposited in their ways, they deposit the materials in different ways. On the basis of the way of deposition, T can be classified into two types: unstratified and stratified. Glacial deposits. A. Unstratified features. Unstratified landform is named till plain, formed due to deposition of loads, of glacier. When continental glacier melts, unsorted or unstratified loads, deposition of glacial happen. It leads to form a plain which is termed as till. Unsorted glacial sediments, plain. Prairie plain of North America is an example. Small plain of such type are also seen near Gulmarg in Kashmir. India. Moraine, boulder, sand and clay deposits are found on the floor of the glaciated region. The unsorted deposits by glaciers are termed as moraine. They are of 4 types. Terminal moraine, as the name suggests, it is found at the boundary of a glacier where it terminates. Lateral moraine. Lateral moraines are formed along 2 banks of a glacier. They are visible when the glacier recedes and the ice is melted. Medial moraine, when a tributary glacier meets with another glacier. Medial moraine is formed. Both banks of both glaciers have lateral moraines. After convergence, both joining banks, lateral moraines, merged together and their sediments are carried in a merged form. Hence, sediments are carried in a linear form from the middle of the moraine. That is why the medial moraines name is given. Ground moraine, when the moving body of ice in the form of glacier is melted, its loads are deposited on the way. Since its deposition is taking place over the entire area of the moving ice, it is called as ground moraine. Drumlin is a depositional topography found before terminal moraine. When the transportation efficiency or carrying capacity of glacier comes to end, they deposit their loads in hips. The axis of the hips is determined by the direction axis of the movement of the glacier. These hips look like inverse teaspoon. It is popularly called as drumlin. Look at the screen. Fig. 5.14. Glacial depositional landscape. B. Stratified landforms. Stratified landscapes are found between glacier and alluvial region. It develops after terminal moraine. Outwash plain is one of the prominent landscapes of such region. When water and ice fragments are flow together, creates or develops a plain. It is called outwash plain. Outwash plains are developed by continental as well as mountain glaciers. Outwash plain is a depositional plain. In this stratified outwash plain some other landscapes are found. Among them Kame, Sander and Kettle are prominent. Kame is poorly stratified deposits found after snowline but parallel to the snowline. This landscape is compared with delta, hence is called Kame. Delta. Kettle is a depression in the outwash plain. It is formed due to melt of a large iceberg. There are found many in the outwash plain. Esker, it is a narrow and long ridge made up of the deposits of gravel and sand. It is generally found on the ground moraine areas. Its side has relatively steep slope. Its height varies from a few meter to several meter and its length is more than a km in the direction of the glacio-fluvial flow. 5.5 CONCLUSION. River, underground water and glaciers are active in different climatic conditions. Depending upon the climatic conditions of any particular area, geomorphic processes are different. You can simply take examples of Indian plains and high Himalayan zone with temperature less than 0 degrees Celsius. Both of these regions have different geomorphic processes. Different processes are working differently. Therefore, the landforms made by them are different as well. It all depends on the way of their actions. That is why William Morris Davis proposed that landform of any region is the functions of structure, process and stage. It is called Trio of Davis, about which you have already studied before. See you keep learning.